In this video we'll learn how to write a function in C. So first, just like always, write your header files. Okay, stdio.h, and then write the main function. Okay, so after writing the main function, okay, write the return statement. So usual structure, whatever you write here. Here you need to define or declare, you can say, the functions. So here I will declare whatever function I want. So if I want to say void display, so this is just a function that I'm writing. Okay, so here I have written the declaration of this function. So now what I can do is I can call this function here. Okay, so this should compile just fine, only it should throw some error for like at the compile time that it does not get this function that wherever it is specified. So let's see how it works. Okay, so function test. Okay, test.c. so here after we have written this thing, we need to do gcc-o functest.o test.c. okay, see here, undefined reference to display, because we have not defined this function, we have only declared this function at this point. So there are two ways you can just continue here itself. Okay, you can write this function, you can write it here only. Okay, this way also you can do, or another way is you can write it below this thing, below main. So here if I write void display, and inside I can write printf \n for the new line. This is a test function. Okay, so just a simple function here. Okay, nothing much complex at this point. Let's see, we have got rid of that error, and now let's run this thing. It should display this message basically. Yes, it is working fine. So now this was just a simple function. So usually what we do is we write functions with parameters. Okay, that is not a general case. Okay, you can write functions without parameter as well, but usually functions do have some kind of parameters. So parameters will have two things. Okay, one is the data type of that parameter, that is integer, and another thing is the name of that parameter or the variable that you will assign here. So that could be anything that you want. Okay, so here whenever you are declaring this thing, you do not need to specify the name of that parameter or the variable name. You can just write I am taking two integer parameters. So this is also a valid declaration. But here whenever you are writing, you need to write int a. I am using that name. You can use any name you want, a and b, that is what I am using here. So let's see. Okay, see here we have not passed here, so that is why it is giving this error. Okay, so let's see here. So here you need not specify the name of those variables. Here it is only a declaration kind of thing, so you can just write two ints. You do not need to give the names of this thing, so that way also it works. But here whenever you are writing that function or you are writing the implementation of that function, just make sure you write the name here. Okay, printf, okay, \n and \n again, value of a equals to %d space \t. okay, b is equals to %d and comma a comma b. Okay, so this is what we have done. Let's see, it will display these values of a and b. So that is the point of this program. And now func test.o, see, it is displaying the value of a is 10, b is 10. If I change these values to 20, it should reflect those things as well. wait a minute. Okay. See here, a is 10, b is 20. So this is simple function that we have written. So functions are of two different types, okay, or you can pass the parameters to this function using two ways basically. Now we are passing the parameters by value, okay. So what essentially happens is whatever you pass here is a copy of whatever you are declared here. So if I write here int x is equals to 10 and int y is equals to 20, sorry, and here you pass x and y, okay. You need to remember whenever you're writing a program the data types should match here. You cannot write here int and pass it as a float or anything likewise. So remember the parameter data type should be the same. If you are passing something likewise that is not same as the source parameter, then you need to do some type casting before you pass, or you need to do type casting on the fly as well, okay. So we will see type casting later, but for now remember that whenever you are passing a function parameters, the data type should be the same, okay. So here we have passed this x and y. So this x and y, so what happens here is a copy of these variables is created. So a and b are copies of x and y. So this takes up a little bit of more space. Like if an integer stores like 4 bytes on this platform, so it will require like 16 bytes. For two variables it will require 8 bytes, and for another copy of this thing it will require 16 bytes, okay. So this also can be saved if we use something called as pointers, okay. So as of now we will not go into deep pointers and stuff, but we will just see how to pass or write functions by, you can say, passing them as a reference, okay. So we will study what is called or what is known as call by reference, okay. So here you can write is pointer. So now here these are pointer variables. So let's see what errors we get here when we change these to pointer variables, okay. So here, okay, change this as well. Okay, and here we need to change it to ampersand of x and ampersand of y. That will give us the address of these things, okay. What, okay, let's declare here as well, okay, sorry. Excuse warning, wait, 26 13 26, okay, this, okay. So here it is a pointer variable, so we have written it directly, so that is why it is giving a warning, okay. If you see here, let's see, okay. So first I will show you directly, I will compile this thing and then I will show you what difference these two things make, okay. See here it is showing the same output. So now what we will do is we will display the addresses of this thing, okay. Printf \n/n address of x is equals to %p, okay. So %p will give you the address of this thing, you can write it this way. So similarly we will write it for y as well, x and y, both things we have to show here. So okay, now here we will display the addresses itself, okay. Send p %p, okay, and here we'll remove this thing, okay. So this should work, let's see. Okay, so here we will show you the difference, okay. So now run this thing, and okay, see here the address of x, see here ox7 fffc whatever that is f0, see here this is same as the value of a, that is address that we had passed here, see here it is same, and this one is also same, see here address of y. So now this we had done using what, call by reference. So now same function we will do with a call by value, display call by value cbb. Okay, let's give it a short form, int a comma int b. Okay, and just write the same thing. Okay, just copy that thing and try to write again, and change this to display cbb. Okay, display cbv. So here we write call by reference. Okay, so just that we don't miss the point here, call by reference. Okay, and here it is call by value, call by value. Okay, so just to demonstrate the differences between the two. Okay, let's save this thing and let's see if we are doing it right or wrong. Conflicting types, let me check. Oh sorry, this is what happens when you copy. Argument of type pointer. Okay, sorry, I should stop copying codes, man. Perfect. So functors dot o. Okay, so see here when you had taken the address of x here, so see here it is showing 20, and for value of a you are passing same variables. All right, see here for this thing whenever you passed it by a pointer you see the same value. Okay, now when the value is passed by value, sorry, it is called by value, see here the difference, it has a very different address. It has like 0c or whatever the address is. This is a hexadecimal address. Okay, memory location. And similarly for the second variable y as well, see here this value of y, it is the address, and here it is referencing the same address. So essentially what pointer does is it saves sort of memory, okay, that would be required in excess. So that is one operation that is allowed in C. Okay, so we'll see about it in the next video. Thank you.